In this video, I'm going to talk about where the formula for the area of a cone comes from, and also where our formula for the area of a frustum comes from. So you don't have to know this, and you're never going to be asked to prove it, but sometimes it's kind of nice to know for your own peace of mind how this works, and maybe it'll make it more memorable in the long term to how the calculus of it works also. So this is optional, but here we'll give it a shot. So here's our cone. In the yellow, you can see our cone, and the area, it's called the lateral area. The area of the whole cone would include that circle that's on the bottom. So the area of the entire cone would be pi r L plus pi r squared. But it's called the lateral area, that kind of rolled up part, the ice cream cone part of it, is given by pi r L, where L is known as the slant height. So the idea is, if you imagine like one of those paper cups that's like that, if you cut it along that side there and then lay it flat, you'll see that it's going to be part of a bigger circle. And so you can see the yellow here that I have traced out on this bigger circle is supposed to be what we get out of that cone once we slice it and then lay it flat. So it's part of a bigger circle. So you can see that when you slice this thing along here, that this slant height becomes the radius of a bigger circle. So what we see is that this area in here is going to be the area that we're after. That's our lateral area, and that's going to be that fraction of the whole circle. So this arc length S right here is actually our circumference of this circle right here. So that S, we can see, is going to be 2 pi r, where the r is that radius in our cone right there. So that means the area of that little yellow sector, that's called, is going to be 2 pi r over that whole circumference of that whole big circle, which is 2 pi L, because that's the radius of the big one. That fraction times the area of the whole big circle, which is pi L squared. Then you can see that the pi's will cancel, one of the L's will cancel, and the 2 will cancel, and all that's left then is our pi r L, and that is in fact that lateral area. That's the area of our cone. Okay, now if we can believe that and establish that, let's move on and look at our frustum. So now we're looking at this area of this piece in here, just that area, not the circle on the top or bottom. So we can see that frustum is part of a larger cone. So the big cone has a radius of r sub 2, and it has a slant height for the whole cone is going to be what I'm calling L1 plus L2. So the area of that whole cone is right there. That's the big cone, is going to be pi, and the radius of that cone is going to be R2, and the slant height is the L1 plus the L2. We're going to subtract off the area of that smaller cone that's sitting on top there, which will then leave us with the area of our frustum. So we're going to subtract off that pi r1 L1. So we start with a little bit of algebra and distribute that, and that gets us to this expression here, and we're kind of stuck a little bit right now. So then I'm going to run back to our stacked cone there, little cone sitting on top of our frustum, and we can see in the blue I have drawn some similar triangles. And in similar triangles, we know that the corresponding sides are proportional. So in the little triangle up on top, we get L1 over R1. is equal to, and in the triangle in the lower right-hand corner, we'll have L2 over, and this distance across here is going to be R sub 2, the area on that base of the frustum, minus the R1, the radius on the circle at the top of the frustum. Then, once we have that proportion, we can cross multiply, and that's getting us L1 times R2 minus R1 is equal to R1 times L2. We can distribute the L1, and then I'm solving this for L1 R2, which we have right here. So let's see what we've got. We've got pi times that R2 L1 is going to now be L1 R1 plus R1 L2, and then we still have this plus pi R2 L2, and also the minus pi R1 L1. Okay, so we can distribute that. So we got pi L1 R1 minus, or plus rather, pi R1 L2 plus the pi R2 L2 minus pi R1 L1. So let's see, the minus pi R1 L1 and the plus pi R1 L1 will cancel. And what's left, I think, has a common factor of pi that I'll take out of one side, and the L2 on the other side, leaving the R1 plus R2, and that's exactly the area of the frustum that we were talking about. So that's kind of where it comes from.